Good afternoon, everyone, and welcome to our live special coverage of Starship Flight 8, the second attempt from SpaceX to launch its fully integrated Starship rocket from southern Texas on the 8th suborbital test flight for the program. Welcome, all of you. I'm Will Robinson-Smith, reporter with Spaceflight Now. As mentioned, you're watching special joint live coverage between Spaceflight Now and Lab Padre. So right off the bat, want to welcome all of you in, whether you're watching on the Lab Padre stream or Spaceflight Now. Be sure to click that like button, share whichever stream you're watching, so more folks can find this live coverage as we cruise on through the countdown today. As was the case with last time, if you have a comment or question about this mission or other happenings in the realm of space and spaceflight, plenty to talk about today, my goodness. You can, first off, best way to do that would be to use the YouTube Super Chat feature, again, on whichever live stream you're watching from. Not only will it be giving us some interesting things to talk about as we cruise up through the countdown, but you'll be supporting what we do here at Lab Padre and Spaceflight Now, and that is always greatly appreciated, my friends. Another way to get comments and questions in is just by clicking or by entering the @ symbol, write the word question, and then type out your question, and it will populate into our little question server here behind the scenes. We'll be monitoring both as well. Last little bit of housekeeping. If you like what you're seeing here with Lab Padre and Spaceflight Now, and you want to support us in a more robust way, you can become a channel member. Channel membership with our channels comes with a number of perks, including member-only exclusive videos, access to members-only Discord servers, discounts at our online shops. So lots of benefits to becoming a channel member, either with Spaceflight Now and or with Lab Padre. Or ideally, both. With all of that out of the way, one last little bit of housekeeping. You can help out our moderators in the live chats by, most importantly, being respectful to your fellow space enthusiasts who are in the live chat with you. Remember, everyone's live stream today could be their first. So you want to treat everyone with the same grace that you would want to be treated if this was your first launch viewing and you had a question or something didn't make sense. If you see something like that in the live chat, you know the answer. Be gracious and answer that for them. Also, as we're beginning our coverage, go ahead and hop in the live chat. Let us know where you're happen to be watching from, whether you're down there in South Texas getting ready to hopefully see this launch with your own eyes, or you're elsewhere around the world joining with us here virtually. Love to see where our audience is today. We hope you're all having a wonderful week. With all that out of the way, we've got a lot to get to over the course of the next less than 2 hours now, currently T-minus 1 hour, 54 minutes, 58 seconds, and counting to the planned launch of this Starship rocket. Things will get rolling with the call from the SpaceX launch director on the start of prop load. That's coming up here T-minus 1 hour and 15 minutes. We'll talk more about the countdown timeline here in just a little bit. But before we get much further, want to welcome in our guest today. If you were here with the last attempt, you are lucky enough that he is back again once more with us, Mr. Zach Golden of CSI Starbase fame. Zach, how are you doing, my friend?
I am great. Good afternoon, everybody. Happy to be here again today. Feels like a bit of deja vu, a little bit. I'm excited for a successful attempt this time. What do you think? What do you think we're going to see? Oh, not sure if you're able to hear me there.
I've got
Okie dokie. Well, I guess I'll just keep on rolling. Yeah, happy to be here with everybody today. I see everybody in the chat saying where they're from. Nice to see people from pretty much all over the place.
Yeah, got them.
If those, you're good to go there, Will?
Yeah, sorry, little technical issue on my end. Go right ahead.
No worries, no worries. I was just saying it feels a bit like some deja vu today, being back here. I always find it funny when you watch some of the live streams from uh, launches that got scrubbed. They end up having to kind of repeat a lot of the same things the next time, so it's almost, like you're watching literally the same program again. But tons of information for us to cover today. I'm hoping for a better outcome. We got a lot to talk about, I guess. So, bunch happened within the last few days as they had to destack the ship and resolve whatever issues they came up with or they ran into during the scrub attempt, and also seemed to create some more issues as they were restacking the vehicle yesterday. So we'll be touching on that today as well too.
Absolutely. And yeah, just to put a fine point on the deja vu aspect of it, the last time we spoke, we were just a few hours coming off of a scrub attempt or a scrubbed launch attempt from the Ariane 6 rocket. So we got one of those check marks on the board with that launch earlier today. Hopefully, we'll have a little bit of a repeat here with Starship launching in an hour and 52 minutes. Fingers crossed that today is the day. The weather's certainly much better this go around.
Yeah, quite a busy day as well. I know. I guess if we're going to acknowledge some other events, we had the Intuitive Machines lander suffer some issues during its um, second attempt at landing on the moon. So I know you probably just got out of listening to that news conference.
Yeah, had to dip out of the Intuitive Machines briefing just to give folks a quick synopsis, though, the highest level points. The lander is on the moon. They have communication with it. However, there is uncertainty as to its orientation. So they don't know for sure if it is on its side at an angle like last time, but it is able to draw power from the solar panels, which is good. They are able to communicate with the four radios on board. The chief issue right now is the high gain antenna, so they're having some difficulty getting pictures back from the lander. And so, without that and without having a firm grasp on the orientation, it's going to be a little tricky to know exactly what of the mission objectives they can fully complete and what still are TBD at this point. But certainly going to be interesting to follow over the course of the next several days.
Yeah, space is certainly hard. I think pretty much every company has had their issues with, um, you know, the beginning phases. Um, Starship is no exception to that. I think we'll probably end up touching on some of that today too, where we're hoping for today based on what happened on the last flight. But yeah, that is really unfortunate. I did miss most of that news conference, but I just happened to get on X earlier a few minutes ago, and I saw Scott Manley post a little animation about a possible scenario for what happened, and that kind of shocked me because as far as I knew, the live stream had just ended, and they hadn't really said anything about the outcome yet. So I found out by seeing Scott's little animation.
Yeah, it was a cute little animation, and we'll see how accurate it ends up being. But certainly an interesting place we find ourselves with the IM-2 mission. I was talking with a colleague earlier today and remarking that if you think about everything that launched on that Falcon 9 rocket with the IM-2 mission, out of all of them, only the Epic Aerospace Chimera Geo satellite bus appears to have worked as intended. Because you saw NASA lost or is struggling to communicate with the Lunar Trailblazer. You have the Odin spacecraft from Astro Forge, which appears to be in a low tumble, and I believe just earlier today they declared that that mission has come to an end. You've got the Intuitive Machines lander itself, which is in some unknown orientation on the moon, and they're using the Lunar Reconnaissance Orbiter to pinpoint exactly where it is and figure out exactly how they might be able to move forward with the rest of the mission. And then you've got Chimera, which is just humming right along. As you said, space is hard, and it doesn't work how you think it might.
Yeah, it's impressive though. I mean, that we've reached the point where they're putting multiple missions on a ride share type mission like that. Just gives you the opportunity to have multiple people carrying out different missions at the same time. I'm interested to see what that looks like with Starship if we ever reach that point where they're doing ride share missions with Starship. I imagine that would be like a once every other year type thing, given the payload volume. Probably wouldn't happen so frequently, but still would be pretty interesting the amount of hardware you can put into space with Starship.
Well, as some folks in our audience may know, but is certainly overshadowed by Starship being used by NASA as the human landing system for Artemis 3 and 4 and likely missions beyond. Starship is also, and SpaceX is also part of the CLPS program, the Commercial Lunar Payload Services program. So even though it has not yet been selected for one of these specific CLPS missions, SpaceX does have the opportunity to bid and be able to carry some of those CLPS payloads like SCALPS, which studies the lunar regolith that's kicked up by the plume during landing on a future Starship lander. So I wouldn't be surprised if not necessarily for Artemis 3, since they'll have plenty of objectives to get through on that one, but maybe as they go through past Artemis 4 or somewhere, maybe with their uncrewed landing demonstration even, that we might see some CLPS payloads be integrated in the future with Starship.
Yeah, certainly have a ton of milestones coming up once they reach the point where the vehicle's actually operational. And I think we're still calling these test flights, but
Can you go to the slide? Oh, sorry. Go ahead.
You're fine. You're fine. Yeah, we're still calling these test flights. That is the phase that Starship is still currently in, even though this is the eighth launch. But we're reaching closer to it actually being considered a fully operational rocket. So today they do have four dummy dummy satellites on the vehicle. Last time I believe they had either 8 or 10, but it looks like they're doing a reduced payload on this one. I think that that's probably related to the fact that they didn't have a ton of these laying around because they were kind of hoping that they were only going to have to do this once, and then more than likely end up actually being able to deploy a real Starlink satellites the next time around. With that said, I'm not sure if that would necessarily be possible on Flight 9 or not, given that they are going to more than likely attempt to catch the ship for the first time on the next flight. So I'm not sure if you're able to reach the proper orbit and then also come back down within the time that we're expecting the ship catch to happen after launch. So, but it is a possibility that after this, they may actually start deploying real payloads into space. All right, I think we're back there. Will, are you coming in through clear?
Yeah, apologies, folks, having some audio gremlins sneaking around our set here, but we should have that all straightened out. Appreciate you bearing with us. So bringing things back to the upcoming Starship Flight 8 mission, Zach, you alluded to the eventful week at Starbase in between the launch attempt on Monday and where we've gotten to today. So why don't we, for our audience sake, wind the clock back to the last time we were with them. The mission had just scrubbed. We saw the post from Elon Musk saying they were likely going to have to stack, take a look at both stages, restack, and press forward. Kind of walk us through some of what we observed through the process of destacking and the key thing that we saw during restack, which happened to make that process take a little bit longer.
Yeah, of course. So, as you said, so Elon kind of elaborated a little bit on the reason for the scrub. He did mention that they were looking at some issues with both the ship and the ground support equipment. So, I believe the system that they use to start the engines on the booster. So, the booster engines are actually, or at least the outer 20 engines are ignited using the ground support system. So basically, injectors within the launch mount that force high pressure gases into those engines to start them up. So that system has to be pretty much perfect to make sure that the right amount of gases are being sent to each engine so that all of them are healthy on startup. And I guess, they're luckily able to detect issues with that before they ever ignite those engines. So I think that was one of the things that Elon mentioned, was that the pressure for that system was coming in low, which is very interesting, actually. Over the last few days, we have seen them swap out high pressure gas canisters, which usually are carrying helium. So they have about like 4 semi trucks with like 20 cylinders on them, and they swapped all of those out, brought in new ones. So I'm assuming that was probably related to that spin start system. So they got that issue resolved. They also spent some time working on the ship, both under the skirt and around the QD area. And that seemed to get handled relatively fast, and they went to restack the ship. And in the process of setting the ship down, it seems like the ship is kind of bounced on the chopsticks to some degree. I think we did see some unexpected play in the chopsticks later on, when there were some folks out there who got some up close videos as they were lifting the ship, and you could kind of see the chopstick, the carriage that the carriage is what the chopsticks are essentially attached to, and what rides up and down the towers. So one of the arms for that carriage, I believe it was Joe Tegmeyer, had posted a video on that showing the arm for the carriage kind of bouncing on the rail a little bit. So they ended up having to stop when they were lifting the ship. And I'm actually getting my timing off a little bit here, jumping ahead in the sequence of events. But when they were going to set the ship down on the booster, I believe it kind of touched down earlier than it was supposed to. As I said, just bouncing a little bit, and it ended up colliding with one of the clamps that are used to secure the inner stage, or basically attach the booster to the ship. So it ended up knocking off one of the pieces that are on that little housing that they have. For matter of fact, I think we have probably some video that we can potentially show of this, at least to be able to explain the components that we're talking about here. But they lowered the ship back down again once they discovered this issue, and got some workers up on the top of the booster to just verify that everything was still good with that clamp. And then when they went to restack, that's when they had that issue with the chopsticks. They had to lower the ship back down, do some grinding on the chopstick rails, and then resume the actual lifting operation. So quite the dramatic series of events, as far as, feeling like, I know a lot of people were saying in the chat a little bit ago that this launch feels cursed. I'm not one of those type of people to believe in superstition, but it certainly felt like that with the series of events that happened after the scrub.
Yeah, I mean, there are plenty of superstitions that folks throw around when it comes to space and space flight. I think just you could chalk this up to things happen. You know, like we had mentioned during our first launch broadcast, this was SpaceX going into a launch attempt without doing a wet dress rehearsal first. And, while that's certainly an important part of being able to move faster as they progress through this program's development, things come up during a wet dress rehearsal that wouldn't necessarily be obvious when they don't do it. And so they tanked with the intention to fly and just found some of the things that they might have found if they had intentionally done a WDR instead of just going into a launch attempt. So I think that's probably the best way you can chalk it up, at least in my mind.
Yeah, for sure. It's nice that you can just turn a launch event into basically a wet dress rehearsal. I think one thing I was saying towards the end of that live stream the other day was that, while some people may say that, oh, wow, this is what, why you should have done a wet dress rehearsal in the first place. I don't necessarily see an issue with it because you're actually saving propellant by doing it this way. So you kind of stack, assuming everything's going to go good, and do a full propellant load, and you can just abort it if you have issues, and then that's your wet dress rehearsal. But doing an actual wet dress rehearsal and fully loading up the ship and booster and expecting to detank it, that actually has a cost associated with it because you're losing some of your propellants in the process and then end up having to replenish what is lost in the tank farm. So it's actually cheaper to go about it the way they did. It is a little bit more frustrating for people who are viewers, especially if you happen to travel down there and you're expecting it to happen one day and then it ends up being 2 to 3 days later, but that's just the way things go with spaceflight, I would say.
Yeah, and want to bring up the tweet that you were referencing a second ago, Zach. Just give us 1 second here, where you were talking about Elon Musk's immediate post-flight comments.
Yeah, so and this kind of expands on what we had saw during the stream or heard during the stream. They went from having I believe having an issue with the booster first, and then then they had an issue with the ship, and then there was another issue right before the end of the countdown. So it seemed like just a ton of things going wrong all at the same time.
Yeah, and if Zach, since you're a little more familiar with this aspect of it, can you sort of expound on what Musk is alluding to here when he mentions being 20 bar below on the ground spin start pressure? You had referenced it in passing before, but now that we've got the tweet up to talk to it.
Of course, yeah. So that's basically that spin start system. There's 20 nozzles inside of the launch mount that inject those gases into the booster, or directly into the Raptor engines. Actually, the 20 outer engines. So it requires a certain pressure in order to properly spin start those engines before they ignite them. And if you are below that, then you're only going to be able to supply enough gas for a certain percentage of the engines, which you don't want. So, making sure that everything is going properly with that is perhaps one of the most important things. I think in the future, this may be something that changes, given that they won't be using the ground support equipment to start the engines as far as we can tell. It'll all be done by onboard systems on the vehicle. So, or sorry, it'll actually be done instead of using 20 individual systems, they'll have just one basically through that large booster QD. So I think that's a little bit more reliable potentially in this situation. But yeah, they had a lot of issues to resolve when they destacked. And I think this is one of those things that hopefully they're able to truly fix and know it's good to go, and not something that requires you to actually reach that same point in the countdown procedure in order to actually determine if the problem is truly resolved.
And do you imagine that conversion for the igniter happening in Block 2 Super Heavy booster, or would that come in a later edition based on your best understanding?
Yeah, so right now they are constructing a new launch mount. That one is a complete redesign, like 100% different than what we're seeing currently. And one of the things that we've been able to gather just by, kind of observing the structure itself as it's been assembled at their production site behind the production facility, it seems like they've done away with that spin start system as far as having the outer 20 engines be started by the internal components on the launch mount. It seems like they're no longer going to be doing that, and instead it'll all be done through the booster QD more than likely. So the two options are, doing it through the booster QD or doing it through the onboard systems on the vehicle, but that actually increases the weight of the vehicle because you have to add high pressure gas cylinders onto the vehicle in order to compensate for what the ground systems were previously doing. So we're pretty sure that it's most likely all going to be done through that booster QD, and that will mean that version 1 boosters, which is what we're seeing right now, version 1 boosters will not be compatible with that new launch mount, and same thing vice versa. So I do think that we'll see this launch pad, even once the second pad B is online, we'll probably still see several more launches off of this one because they'll be hopefully reflying boosters. We may see booster 14 fly again on flight 9 or 10. But I would assume that every booster that returns will probably be reflown at least once from this point on. So in order to actually do that and kind of knock off that checklist item of actually proving that they can reuse vehicles and gathering the data on reuse, they're going to probably continue launching off of Pad A for at least a handful of launches, while Pad B is also operational at the same time, launching the version 2 vehicles.
That would make sense. We'll pause our conversation for just a moment here as we're currently T-minus 1 hour, 30 minutes, 44 seconds and counting. I want to take a moment to pivot over to the countdown timeline for just a second here. Let folks know what we're going to be tracking over the course of the next hour and a half as SpaceX moves towards the planned liftoff of the Starship rocket there. You see live on the right-hand side of your screen. As mentioned earlier in the show, the SpaceX launch director will make the call on the start of prop load at T-minus 1 hour and 15 minutes. That'll be followed by the actual prop load process starting with liquid oxygen on the ship upper stage that begins at T-minus 45 minutes, 59 seconds, followed shortly thereafter by liquid methane flowing on board the upper stage as well. T-minus 41 minutes, 22 seconds, booster fuel load begins, followed about 6 minutes after that by LOX load on the Super Heavy booster. T-minus 19 minutes and 40 seconds, the Raptor chill down begins when they're thermally conditioning the Raptor engines on both the Super Heavy booster as well as the ship upper stage, since the upper stage engines will come into play fairly quickly into the mission with that hot staging event. T-minus 3 minutes and 20 seconds, ship prop load wraps up. That's followed 30 seconds after that by prop load on the booster, at which point the Starship rocket will be fully loaded with all of its propellant and ready to go. T-minus 30 seconds, the SpaceX flight director will verify their go for launch. Just a quick note here. If SpaceX does need to enact a hold like it did last time, that would kick in at the T-minus 40-second mark, and they can hang there for several minutes and make adjustments as needed and recycle the count back to T-minus 40 seconds. T-minus 10 seconds, the flame deflector is activated. As SpaceX commentators have noted in previous broadcasts, though, if they get to this point where the flame deflector does activate and then there's an issue either on the ground system side or on the rocket itself, they would need to scrub at that point, since they would need to refill the water system before proceeding into another launch attempt. But if all goes well, T minus 3 seconds is when the Raptor engine ignition sequence gets underway. And then at T0, as SpaceX likes to say, excitement guaranteed. Now T minus 1 hour, 28 minutes, 10 seconds and counting until that point of excitement. Again, as a reminder, feel free to use the either YouTube Super Chat feature or the @question function in the live chat if you have a comment or question about this mission, other happenings going on around Starbase, or just in spaceflight in general. We'd be happy to answer those to the best of our abilities between Zach and myself. So, Zach, last time we were talking with this launch opportunity on Monday, we were surprised in the middle of the broadcast with the breaking news of an update from SpaceX talking about the future of Starship down here in Florida and the establishment of Gigabay along State Road 3. I believe the road that you're actually seeing primarily in this image here is a road that runs parallel to State Road 3. So for those who have taken the bus tour up to the Apollo Center as part of the Kennedy Space Center Visitor Complex, you may recall seeing the Hangar X site on the left-hand side of the road if you're heading north. And that would be where you'd see that towering building that's going to be roughly 380 feet tall, about 46.5 million cubic feet of interior space. We do have some additional information that we've learned since then, that according to the Florida Department of Commerce, this will also bring about 600 new full-time jobs to Florida Space Coast by 2030. And SpaceX plans to invest about $1.8 billion of capital into making this happen. And that'll go towards the support of Starship launches from, at first, Launch Complex 39A there at the Kennedy Space Center, and perhaps further down the road from Slick 37 at Cape Canaveral Space Force Station. So, Zach, now that you've had a little time to marinate and it's not happening in the immediacy of things, I wonder your thoughts on all of these updates on the Starship program, Florida edition.
Yeah, definitely. We've kind of been waiting on these for a while. We do have some folks in the Discord channels who are constantly hitting refresh on the website where they post all of the basically the regulatory approvals, so the permits and whatnot for construction. So kind of have been expecting this for a little bit, with SpaceX planning to expand to 39A. They're definitely going to need a full manufacturing facility down there. So they had previously started to construct that facility. So they did have a Star Factory down there, which actually ended up being converted over for, or I shouldn't say converted because it was never fully built out anyways, but repurposed for Falcon 9 operations. So now they have another lot near, adjacent to that same facility where they're going to be building out the Star Factory for Starship. And that will, of course, include that Gigabay. So, that a big change of plans from what they were initially planning to do. I think they were going to have 2 megabays face to face. That's kind of what it was shaping up to look like. But this is a much larger structure that is essentially, I want to say, nearly 3 of those megabays combined. So not only taller, because the new booster and ship will both be taller. So the booster especially will not fit in the current megabays at Starbase. So ever since the announcement of the version 2 and version 3 boosters, we've essentially been expecting that they were going to have to build new facilities, especially at Starbase. So I think that it's been almost a full year now since that announcement. So I've almost a bit shocked that it hasn't happened yet as far as initiating that construction process. So at Starbase, they do have the high bay, which is probably or more than likely in the footprint of where this new building is going to be. I believe the Mega Bay 1, which is where they construct the boosters at, is probably also within that footprint currently. So the high bay previously was used for ship assembly and also a little bit for their test tanks. So, kind of all the random things that they didn't have dedicated workstations for in Mega Bay 1 is what they have been doing in there. So we've basically been waiting for them to stop using it. I think they've also done some ship scrapping in there as well too recently. So they finished scrapping the last ship. They have started moving everything out of that building, and now we're expecting that they will start the process of dismantling it. And that goes for the adjacent Stargate building as well, which I think previously held a lot of their offices and workstations and whatnot. So now that the office building at the Star Factory is mostly completed, they've begun moving a lot of their offices over to that structure. And now we're reaching the point where they should start demoing those buildings here soon within the coming weeks. Going to be a long process, I think, because it's a very tall structure. So how they'll bring that down, I'm not sure, whether it's going to be like piece by piece or drop the whole building at once like they did with the smaller mid bay last year. But yeah, it's exciting times coming. Once they do that, they'll start constructing that building. I think it'll probably be done in phases, given that it'll cover so much area. So they'll probably complete half of it, then demolish the Mega Bay, and then continue constructing the second half of that building over that remaining area. So going to be very, very large structure. Not quite as large as the NASA VIB, which is, I believe, 500 and I'm going to say 25 feet tall. It's getting close though. And the amount of workstations that they'll have within this, I believe they said, and correct me if I'm wrong, I think they were going to have 12 additional workstations from what they have currently. So I believe right now they have technically 5 workstations in there. So that would be a total of 17 to 18 workstations. So they'll mostly be constructing ships in there, I believe. More ships than boosters, probably ratio of ships to boosters, because the boosters will be flying a lot more often than the ships will. So most of that space will be for Starship assembly, and that'll dramatically increase their output from what they're doing currently. I think they're still in the process of kind of ramping things up here at Starbase, but so we don't truly know what their manufacturing rate looks like with their current state of affairs. But it's certainly going to be increased at least twofold, if not more, once that facility is operational.
Yeah, and just to buttress what you're saying with some numbers from SpaceX here, they note that compared to the Mega Bay at Starbase, the Giga Bay in Florida will have 19 additional work cells and twice
Wow.
the crane lifting capacity. 24 work cells for integration and refurbishment work. And you were very close on the height of the VAB, 525 feet tall. But you were basically bang on the money.
Yeah, that is a pretty large building. I think a lot of people were expecting actually that SpaceX would end up leasing space within the VAB. I'm not sure if that is an option that is probably still on the table as well, like, to expand beyond what they're going to have with that gigabay. But yeah, I haven't heard anything additional about that for quite a while.
Yeah, I know there was some reporting suggesting that High Bay 1 had been leased, but as last I remember checking in with folks at the Kennedy Space Center on that, the entity, I'll say, who was going to be moving on that had not actually taken any action with it. And so the Kennedy Space Center wasn't at liberty to discuss who the prospective tenant would be. But, I think you can draw some conclusions on what might be, just given on all the players who may have interest in that much space. We'll just also draw our audience attention to things here at Launch Tower A. We are seeing that tower venting that we talked about last time. So this is coming ahead of the start of LOX load on the ship upper stage. And Zach, correct me if I'm wrong, but the venting we're seeing near the bottom, actually, if we can go to this other view right here, I think you can see near the base of the orbital launch mount that additional venting, suggesting that all the cooling procedures are basically in swing now as they're getting ready to make the call and start a prop load in about 2-ish minutes, if they haven't already.
Yeah, it seems like they're a bit ahead of schedule. I don't have the schedule up in front of me, but yeah, it seems to me like they're slightly ahead of schedule. But yeah, that tower vent certainly is going. The launch mount one, it's a little tough to see for sure on that. Actually, sorry, yes, I do see it now. So yeah, definitely picking things up and probably going to be on time today. I think yesterday or the previous attempt had about a 30-minute delay. So I don't think we'll see that this time.
Yeah, no, I was just checking to see if there's any word from SpaceX that they had, in fact, made the call and start a prop load, but not seeing anything just yet. But all these visual cues certainly seem to suggest that they're in a good position to proceed with that.
Yeah, one thing about the few times that launches have gotten pushed out, it tends to work out for the better, in my opinion. The weather is far better today, so going to have a lot greater visibility this than if they had have launched 2 days ago. And I think that was the case the last time it got pushed as well. So, everything happens for a reason.
Exactly. Speaking of things happening for a reason, given the signs that suggest that prop load is, in fact, been given the green light to move forward, the next step, just to remind folks, or for those who are not here, when we step through the countdown timeline, fueling begins the T-minus 45-minute, 59-second mark with liquid oxygen on the ship upper stage, which is why you're seeing that tower venting right now.
Yeah, so we're still about 30 minutes out from that. That's why things do feel like they're moving faster right now.
Yeah, just about 30 minutes out from fueling. And one thing that we did talk about last time, which obviously is going to be top of mind for folks this time around, is making sure that ship performs as they're expected to. And part of moving through that was doing this extended static fire test on S-34. Zach, for folks not as familiar with the importance of a long-duration static fire test like this, can you explain why this one, which is significantly longer than other static fires we've seen on previous ships, was so key, and especially proving out this Block 2 version.
Yeah, definitely. So this static fire was, I would say, almost 5 times longer than anything that we've seen before. And, this was very important for them to do given the outcome of Flight 7 with the ship. So they did have issues with the engine plumbing. I think they had a lot of vibration within that engine plumbing, which ended up causing something to fail and actually end up leaking within um, they call it the attic of the engine bay. So basically a void space where there's engine shielding to protect all of the components above the engine nozzles. And it's a very large void space, which, if you have a lot of gas buildup in there, and obviously the flames from the engines just below, something is bound to end up catching fire. So that's pretty much what happened last time. And this was kind of a result of some upgrades that they made to the engine plumbing. So the version 2 ships are completely redesigned as far as the propulsion system goes. So still using the same engines that they had on the V1 ships, which actually won't be the truth for much longer. I think in the during the scrub attempt, the SpaceX announcers mentioned that they will be integrating V3 Raptors on. I didn't actually hear whether or not they said it's on the next launch or the one after that. But either way, it is coming soon. So, the new propulsion system basically separated out the pipework for those engines instead of all coming from one common, one larger pipe. They actually separated it out. So each engine has their own supply of liquid methane. So with those smaller pipes, and I don't know if we can show that again. We did show it last time, but for those of you who are joining us today, it might be helpful for us to show it again if we have that ready to go.
But stand by. We're seeing if we can get that back.
No worries. Yeah, so I can kind of keep explaining. I think he's got it up here right now. So yeah, they made this big change, and it seems like their intention was to, as I said, have dedicated supply for each engine. Tell you the truth, I'm not really sure what kind of benefit you get from that. I do think that they, especially with the Raptor 3s coming out, the actual consumption rate of both liquid methane and oxygen is going to increase. So I don't know if this is something that they're trying to do in preparation for that. But you can see on the left side the original old ship design where they have one, we call it a downcomer pipe coming from what would be the methane tank above. And so that splits off 3 ways once it gets to the bottom. And those 3 pipes are for the outer 3 vacuum Raptor engines. And you can see on the right side, the new ship design, they actually split those off before it even leaves the methane tank. So each engine has its own dedicated supply. Each of the RVAC engines have their own dedicated supply. And those pipes are quite long. Even just having one of them by itself, you only have to worry about, vibration effects through one downcomer pipe, but now there's 4 of them. So with those being smaller for each engine, I think I was kind of wondering when I first ever saw this what would end up happening as far as the added failure points that are now introduced by doing this. So it was interesting for them to end up actually having issues with this during Flight 7. And really the only way to test it, because this happened so late into the burn for the ship, is really to do a long duration static fire test. So, after running into that issue, they basically wanted to recreate the same situation, and that required them to do a long duration static fire test. So I would assume that the data they got back from that gave them confidence for today, or else they would probably still be working on some sort of fix for it. So I do think that hopefully that issue will be resolved today. But Lots of work goes into learning from problems that they find during each flight, and that being a very big one. I'm sure they don't want a repeat of that. They've got some other important tests they want to do today as far as that deployment of the dummy Starlink satellites, and also with the upgraded design for the flaps on the ship. And they want to make sure that they're able to test the performance of those during reentry, and as well as the experiments that they have with for the TPS protection tiles on the ship. They want to get data back from that, and kind of further along that research and development process for those TPS tiles. So, with I would say that's one difficult thing for that team in particular, is that the best data that they're going to get is by actually recovering a ship. So with the pretty much every other department, whether it's avionics, propulsions, those teams get live data back during flight, and they are able to see things that they need to make corrections on. But without actually being able to bring the ship back and study the aftermath, that TPS tile development team kind of gets the short end of the stick a little bit. They're really hoping that this time around they'll actually be able to recover it, and so they'll be able to gather more data and actually make greater improvements on the overall design. They do have some experiments that they're running on this as far as with intentional tiles that have been removed and are basically relying on the thermal blanket underneath. And they also are using some metallic tiles as well as some actively cooled tiles as well. So, they really want to actually be able to test that stuff. So, making sure that the propulsion system is doing what it's supposed to do and not causing loss of communications or loss of power to those other engines, that'll be very critical for everything else that comes after that.
Yeah, you can't get anywhere close to recovery if you don't complete your first burn. We did have a question come in from Pete's guide over on the Lab Padre side of the stream here. Harkening back to part of our conversation where we were talking about if there was some kind of issue that came up in the countdown once they got to the point where they had activated the deluge system, why they would need to scrub for the day because of that. And Pete asks, do you foresee SpaceX adding a pipeline or water desalination plant so they can refill the water tanks quickly? Zach, I know obviously you keep close track of all of the infrastructure alterations that are made to Starbase. Is that anywhere in the plans as you're aware of them? Or is that just, not in the cards and doesn't really make sense?
Yeah, I mean, I think once they reach the point where their launch cadence has increased to the point where they're launching multiple times a month or possibly once a week, then that will definitely become necessary. Having a continuous water supply that doesn't require shipping in loads of water. I think there's a lot of regulatory
Also,
approvals that go with that. Sorry, go ahead.
Sorry to cut you off real quick. Just want to let folks know that SpaceX just issued a statement saying team is go for prop load.
Awesome. Here we go. Yeah, so I think there's a lot of approvals that have to go with that because a lot of water treatment processes involve creating a lot of wastewater. So I know like with RO, reverse osmosis water, you basically have your clean filtered water stream and then a stream of brine, which is basically everything that's removed from that water. So you can't just only remove the solids. You actually still end up with a waste product as far as water goes. So one way or another, I believe that they would still end up having to tank water away, like ship water away from the site. So they probably have a storage facility that's storing all of that wastewater, and then they got to send it somewhere to be processed. So it may actually, for now, be cheaper for them to only have to worry about shipping in clean water and not have a massive stream of treated water or wastewater that they then have to do something with. So yeah, the economics kind of have to work out for that to become something that they consider doing. They do currently, right now, I believe, source most of their water from a uh, in Brownsville, like near the bottom of Highway 4. So basically, just a neighborhood down there. So you know, for now, I think that that works out well for them. They don't really necessarily have a need for a continuous supply right now. I think it only takes, they said, about 24 hours to replenish that system. So you know, that's enough as far as fast refill goes.
Yeah, and certainly when you're talking about making big changes, especially where it concerns having to deal with wastewater and really anything that involves changing the water system surrounding something like Starbase that has garnered so much attention, especially from certain environmental groups that are watching any type of large changes very closely. You want to make sure that you make the changes when you have to and that it is as buttoned up as possible since Starbase abuts the Boca Chica Wildlife Refuge and, of course, is currently in the process of working towards incorporating with a vote coming up. I think uh, early voting starts in April, and the full in-person vote is in May. That coincides with another set of local elections. So it'll be interesting to see how an incorporated Starbase may have some different parameters or may be able to function differently as far as the timeline for some of these infrastructure upgrades. Now currently T-minus 1 hour, 1 minute, 46 seconds and counting. As we mentioned just a second ago, SpaceX has confirmed that they are go for the start of prop load today, which is set to begin here in about 15-ish minutes. The fueling on Starship will begin with the ship upper stage. LOX begins to flow at T-minus 45 minutes, 59 seconds, and liquid methane at T-minus 42 minutes and 59 seconds.
Yeah, one thing to mention here that we did cover last time as well. So with this prop load being around 45 minutes, it is a pretty large increase from what we were seeing for the first three flights, which was about 90 minutes. So they have dramatically sped that up, and we are expecting, with all of the upgrades that they're making to the tank farm, that this will drop even further. So we're currently estimating that once they start operations on the Pad B launch site, that will probably drop to around 30 minutes. So that will be very interesting, and it's incredibly fast loading time for a vehicle of this size. And I'm a little nervous for it because it does reduce the amount of time that you have to detect issues and actually address them. So, I guess it may give them a little bit more standby time. So, by loading the fuel faster, it'll, by the time you're done, the average temperature will still be colder than it would be after 45 minutes, right? So you have an additional 15 minutes essentially of hold time that you can address issues with. I think that you probably have a correlation like that. So, not only obviously does it allow them to load faster, but it gives them increases the size of their actual launch window.
Yeah, I think that's a good point. I mean, essentially makes it analogous to Falcon Heavy fueling timeline, if not just a hair faster. But, to bring it down to within 10 minutes of the start time for fueling a Falcon 9 rocket is certainly quite remarkable. And I think to your point, given the volume of propellant that they're loading on, they'd ideally want to do it as fast as possible to keep that average temperature as cold as you physically can, as is reasonable. And presumably would allow them to use less of it as they're tanking.
Yeah, definitely. They seem to be taking a lot of steps to increase that amount of standby time that they have. They do have insulated pipes that they use for keeping the liquid cold as it's being delivered from the tank farm to the booster. They have upgraded those for Pad B, so instead of just having sleeved insulated pipes, they are actually vacuum sealed pipes, so they'll should have a little bit better ability to keep that propellant cold. And it's just another step towards improving the efficiency of their launch operations.
And as they continue to iterate on this vehicle, one of the things that they mentioned going into Starship Flight 8 was, in addition to redesigning the propulsion system on the upper stage, they also state that they have included a, quote, 25% increase in propellant volume over previous generations, end quote. Given the ultimate long-term goals for Starship, Zach, why, in your mind, is it important to increase the propellant volume by that much, and how much more do you think they would optimally like to see volume get to?
Well, I think a lot of it kind of has to do with their ability to perform certain missions. So right now, one thing we don't know is how much of the fuel load actually ends up being drained before landing. So they do end up, especially with the booster, you can actually see after the hot staging, they do actually purge away a lot of that remaining fuel. So you'll see like a huge cloud coming from the bottom of the booster after the end of the boost back burn. So they kind of just ditch remaining fuel. And we don't know whether or not they do that with the ship currently, because it's very difficult to see when it's given the views that they actually show. So, increasing the propellant load may actually be something that they're kind of forced to do in order to actually be able to do full real missions where they're actually launching payloads and doing multiple orbits instead of just coming back down in the Indian Ocean. So I think they may have no other choice but to add that additional propellant. And especially with the upgraded Raptors, the consumption rate of that propellant is going to increase even further. So I think it's all interrelated, but I think it's, like I said, something that they don't really have a choice other than to do.
Yeah, that all makes sense, certainly. Just for a quick point in time, T-minus 55 minutes, 16 seconds and counting. We are just about 10 minutes away from the start of that prop load. Once again, with LOX first, then liquid methane starting on the ship side before moving to the Super Heavy booster. We mentioned earlier in the broadcast a little bit about the role that Starship is going to be playing in the future of the Artemis program, obviously acting as the human landing system, which will bring astronauts down to the surface of the moon on both the Artemis 3 and Artemis 4 missions as they're currently designed. One of the things that may not be as top of mind for folks in the whole process is, once the astronauts are on the surface of the moon, what the comms system will look like when they're actually outside of Starship and beginning to move farther and further away on missions, thinking as far out as Artemis 5, when the plan is to have a lunar terrain vehicle on the moon's surface, and they'll be able to drive some distance away from the lander that's being used. So one of the things I wanted to bring into the conversation here before we turn back to Zach is, before the launch of the Intuitive Machines IM-2 mission, we had the opportunity to speak with some of the leadership from Nokia and Bell Labs, which has an experiment and a technology demonstration on the IM-2 lander, as well as one of the rovers and micro hopper, which is a 4G LTE communication system that will allow that type of comms between both the hopper, which will, assuming it can still operate as intended, move quite a distance away from the lander, and the rover, which will move at a much slower speed and not nearly as far. Want to take part of that conversation, play it for you now, since in this part of our chat, we talk about how they're planning to learn from that demonstration that's going to be happening now or in the days to come, and apply that to the future Artemis missions, allowing communication from the EMU suits that are being developed by Axiom Space and with the Starship lander. So this is part of our conversation, talking about the future of communications with Starship and Nokia.
So functionally, it's very similar to what we're doing on the IM-2 mission, but now we put it into the spacesuit. So from a network architecture perspective, we'll have that network in the box on the HLS, the Human Landing System for Artemis 3. We'll have the user equipment now integrated into the suits, the way now it's integrated into the rover or the Micronova hopper. So architecturally, it's very similar. We have a multiple user devices, a network, and we establish a wireless link. We evolve the system that we fly on IM-2, we evolve it for the Artemis 3 mission. And then, of course, from an application perspective, we're now adding voice, and we're adding biometric telemetry data from the suits, in addition to images and streaming video from helmet-mounted cameras. And so that's architecturally it's the same. The use cases are very similar to what you would see on a terrestrial network. We're now adding the voice capabilities, and then we'll support EVA activities as the astronauts go out on the lunar surface. In the wireless system, there's really two parts. One is the capacity, which is how many users are you supporting, and what's the data rate that you provide to each of the users. The other is the coverage, which is really how far can users go and still be able to connect and transmit that data and receive that data. It's really a bidirectional network. And you're absolutely right, the higher you mount the antenna, the better off you are in terms of your coverage. What drives your coverage is your propagation environment. Do you have buildings? Do you have obstructions? Obviously, we don't have a lot of that on the moon. Then it drives your power, your transmit power, your antenna design, which you can independent of your deployment, really. But then how high you mount the antenna. So mounting the antenna on an HLS versus Athena will definitely give us extended range. And just for comparison, in the IM-2 mission, we target up to 2 kilometers. We know that with the IM-2 configuration, we can reach beyond 2 kilometers, but the ConOps of a mission calls for 2 kilometers based on where the rover will be driving. With an HLS, we expect to go up to 10 kilometers. And a lot of that is driven from just the mounting at higher heights for the antenna.
And I want to thank Thierry Klein, the president of Bell Labs Solution Research, part of Nokia, for sitting down with us and talking about their mission, both on IM-2 as well as the future of that technology, as you just heard, with the Artemis 3 mission and beyond. Now, currently T-minus 49 minutes, 55 seconds and counting. At this point in the countdown, the ship LOX load is just about 4 minutes away from beginning.
Yeah, it's really awesome. You can always tell when they're getting close to that. The venting from the tower starts to pick up quite heavily. The same thing with the launch mount. So you can kind of see both of those from this angle fairly well. So we will see that tower vent tail off here soon, and then within the next few minutes, they'll begin loading liquid oxygen onto the ship.
And why is it, Zach, that the vent really kicks up here at this point in the final minutes before loading actually starts?
Yeah, so basically they have these really long pipes. I think they're about 19 inches inner diameter, so they're fairly large. You could almost crawl through them. And they need to chill those down before they begin loading propellant because they want to essentially reduce the time that the propellant has to actually heat up. So they don't want it already heating up before it is even inside of the ship. So they need to pre-chill those lines down as cold as possible. So they'll actually start trickling slowly pushing the liquid propellant through those pipes and allowing them to reach their minimum temperature. And in the process, that liquid oxygen is boiling off pretty fast. So they have to essentially open up a vent on the tower and also on the launch mount and bleed off all of that vaporized oxygen gas. And as the column of fluid begins climbing up the tower, that venting actually increases. So it has less time to actually warm up in those pipes, and so it becomes more visible as it's coming out of those vents. So that is basically a sign of that gas flow slowly transitioning over to a liquid flow, and they will actually sometimes let that liquid actually flow out of that vent for a while and then close that. And once they close it, they almost immediately start loading liquid oxygen onto the ship.
And for those who are familiar with our live streams at Spaceflight Now with the coverage of the Falcon 9 rockets, we refer to that as the big vent, but it's a similar process where they're chilling the feed lines, and then you see that boil off of the liquid oxygen, the gaseous oxygen, as the lines are chilled. And we should be coming to the conclusion of this vent here pretty shortly, as we're now less than 2 minutes away. Looks like a Coast Guard helicopter that just flew by, if I'm not mistaken.
Yeah, it seems like they actually have two of them rolling right now. In previous launches and even during the scrub attempt, I think we only saw one. But a little bit ago on the Sentinel cam that looks at the build site, we did see two helicopters land and kind of get refueled right there. So they're basically about a mile and a half, almost 2 miles away from the launch site, getting refueled and hopping back up in the air and kind of just basically in charge of range safety, making sure that there's nobody within the exclusion zone. And that basically helps them have pretty much seamless countdowns as far as not having range violations.
Yeah, and for those unfamiliar with the exclusion zone policy, that can either be violated by a watercraft that's inside the keep out area or an aircraft that is flying where it ought not in the critical point leading up to liftoff. And so those helicopters are part of, as Zach was just saying, the patrol to make sure that those areas are clear well in advance of both fueling and, of course, once they get down to the point where they're ready to launch. Speaking of fueling, T-minus 45 minutes, 28 seconds and counting. LOX load now underway. Should start to see frost line form on that LOX tank on the ship upper stage. That'll be followed by liquid methane flowing at T-minus 42 minutes and 59 seconds.
Yeah, we did just see that venting on the tower shut off, and right as you said that, so pretty much good to go on that. We actually do see the methane subcoolers in the background over there as well too, so they're preparing to begin with that as well.
And just to direct folks' eyes, those are in this frame here on the bottom left-hand corner of your screen, right?
Yes. And it seems like SpaceX has, I believe, shortened their stream for today. So
yeah, it looks like they're starting in about 10-ish minutes, so a little bit shorter than last time. As we're preparing to see the next step of fueling, which is coming up here, actually just now getting underway, liquid methane now flowing on board the ship upper stage. That beginning just about 10 seconds ago. In just a little more than a minute, we'll see liquid methane start to flow on the booster stage as well. So far, as best we can tell, all moving as expected. SpaceX confirming that prop load of the upper stage and the Super Heavy booster are underway now. So barring any hiccups between now and T0, things are moving towards a good launch. Of course, we'll continue to keep tabs and give you any relevant updates as they come along. But let's go ahead and talk about where this Starship is going to fly once it does leave Launch Tower A. Its mission will look largely similar to what we saw during Flight 7 with an initial liftoff from the pad. It will fly largely in an easterly direction once it lifts off from the Starbase area. About 2.5 minutes, the booster will have most engines cut off, and you'll see that hot staging process. The hot staging ring will be jettisoned as the boost back burn happens and brings the ship back to the tower. Of course, if SpaceX feels like they are not in a good position for a tower catch, they will divert to the Gulf instead. That'll be followed by the deployment of the dummy Starlink satellites and in-space relight demo, and if all goes smoothly, we'll see a splashdown propulsively in the Indian Ocean off the coast of Australia. That'll happen a little more than an hour into the flight, about an hour and 6 minutes is when that splashdown propulsively is expected in the Indian Ocean today. Just as a reminder, now T-minus 40 minutes, 14 seconds and counting. If you have a comment or question about this mission or would just like to offer some support with our coverage across Lab Padre and Spaceflight Now, feel free to use the YouTube Super Chat feature. And not only will you be giving us some interesting things to talk about through the countdown, but of course you'll be supporting what we do here across the channels, and that is always greatly appreciated. Also, you can use the @question function. Just type the @ symbol, the word question, and write out your question. And of course, if it's appropriate to be read on the show as well, we'll be monitoring that, looking for some good things to discuss throughout the next 40 minutes. One question coming in from Glenville Goggerly. Question: what Starship flight test do you think SpaceX will attempt a ship catch, and why are they waiting to test this maneuver? We talked a little bit about this earlier on in the broadcast, but Zach, seems like one of the big things they want to go through, obviously, number one, going through a full nominal flight test as this mission is laid out with a Block 2 ship, but also to get some good data on how the in-space relight does, and then I guess thirdly, and perhaps most importantly for a catch, is seeing how the heat tiles around the catch fittings hold up, and if they feel like the structural integrity will be there for a future catch. Are those kind of your top three, or is there anything else that I'm missing in that list?
Yeah, definitely. So they do have the catch fittings installed on this ship. They are not real ones. They are basically to kind of simulate the real thing. They don't have any like structural integration with the actual vehicle. They're just bolted onto the side of the payload bay, essentially. So they are basically hoping that they're going to get good data on that. If they are able to recover the ship, that'll allow them to analyze that fitting and basically determine whether or not they need to add some extra protection around it or additional reinforcement, possibly different material selection on that. And then if everything turns out good with that, then Ship 35, which is the next one in line, has catch fittings already installed on it. And those are structural fittings that are integrated into the actual structure of the vehicle. So they're load-bearing pins, which will mean that once they land on the chopsticks, it'll actually be able to support the weight of the vehicle, whereas the ones that are on there currently would just shear off. So they are not able to land with these ones, but on the next flight, they will have essentially real catch hardware installed on the ship. And we are expecting that, similar to the booster, they will want to test this as soon as they feel confident that everything will go well. So obviously it's still going to be a huge question mark, but in my opinion, does seem a little bit more difficult than catching the booster, especially considering that we do expect it to happen on pad B. So they will catch the booster on pad A and probably only do 1 or 2 orbits with the ship and then come back in for landing. So given that it may potentially happen within an hour after launch, the booster will probably still be suspended from the chopsticks on Tower A, which means that they have no choice but to land on Tower B. So they have been putting a lot of work into getting those chopsticks operational on Pad B. They've done some testing, lifting the chopsticks up and actually extending the arms. So after this flight, we expect them to probably do some structural qualification testing where they bring out these very large water balloons, essentially, that are attached to the tower. They usually load anywhere between 150 to, I think they got up to like 450 tons that they suspended from those on the most recent time that they did it. So, do some structural verification testing. They also will be doing structural verification testing on a test article of the ship. So basically making sure that it's able to withstand the forces by the chopsticks as it's essentially hugging the vehicle. So, all the preparations are underway, which is very similar to what happened with the booster ahead of Flight 5. So, performing all of those verification testing so that they know that once they do it for real, that everything will turn out as expected. So really the only question mark will be how those tiles look when it comes in and how the ship hardware actually holds up. I think they do have that landing maneuver down pretty well. They've done it several times at this point now. So I think that they're pretty confident that as long as the actual hardware holds up, the ship will do its job the rest of the way. So that'll be really exciting. Hopefully everything turns out well and they're actually able to recover this. I think that really depends on the condition of the ship, obviously, when it falls over. So I think that's always been, in my mind, a very challenging thing. I think they expect it to remain intact after falling over, but I've always questioned whether or not that will ever actually happen because it's just such a large vehicle, going from being basically upright in the water to falling over. The ship is about 50 meters tall. So, especially with the new engine hardware that they've installed as far as the additional downcomers for each of the RVAC engines, I think that adds a lot more opportunity for failure when it tips over. If any of those pipes were to break, then all of a sudden you have methane leaking inside of the oxygen tank. So it pretty much is an immediate explosion if that happens. So the key, I guess, will be for them to actually somehow get it to not explode when it tips over in the water. So that is going to be a big thing that I think they've been planning for and trying to improve as far as the robustness of the ship.
Yes, indeed. And just want to note for folks as well that we are now T-minus 33 minutes, 11 seconds and counting. At this point, the last bit of fueling that had not begun lockstowed on the booster is now in works. So we've got all 4 tanks on this rocket that are in the process of filling, and so far things have been moving smoothly towards a planned liftoff coming up here in just a little more than half an hour from now. We are expecting to get some drone views from SpaceX coming up here in the next, would have expected by now. Looks like they're running a little behind on the start of their broadcast. So we'll be sure to bring those views into you when they are available.
Yeah, they do seem to be live on X, but on their actual website, it hasn't gone live yet.
Let's see, we did have another question that came in. Dark Rider VR asking a question about where the ship upper stage ends its mission as the trajectory currently lies. Essentially, why do they ditch Starship by Australia and not make it land near Texas or Florida? Thanks.
Yeah, that's a good question. I think some of it may have to do with not wanting to fly over land at all with the ship. So they do kind of fly over the Turks and Caicos, but I think they like skirt right by it. But by flying their current mission profile, it never passes over land. So I think that may have something to do with it. I think there's another reason as well. I just can't remember it off of the top of my head.
I think that's essentially the principal reason is, like you said, to avoid flying over land at the moment.
Looks like SpaceX just sent out a tweet that the live broadcast starts now. So we are getting ever closer, about 30 minutes out.
Yep, things are certainly seeming like they're lining up pretty well. So we're currently T-minus 30 minutes and counting. Coming up here, the next milestone in the fueling process is going to be at T-minus 19 minutes and 40 seconds when the chill down of the Raptor engines on both the booster and the ship get underway. As mentioned, with the launch timeline, once liftoff happens, they go into hot staging less than 3 minutes after liftoff. So you want the engines, the Raptor engines on the boost or on the ship stage to be ready to go pretty much at the point of liftoff. So you don't have to chill them in the post-liftoff timeline. just listening into the SpaceX commentators here, Kate Tyson, Dan Hewitt, Dan Hote, talking about the holds that were triggered last time. As we mentioned earlier in the broadcast, Zach, we heard them mention that there were a couple of engines that came in at a little bit under pressure with the that spin start system that we were talking about. And as they were getting through clearing that hold issue, then they triggered another hold item that was connected to the liquid oxygen tank on the Super Heavy booster, saying that there was just a misaligned configuration.
Yeah, it's impressive. There, are thousands of things that can trigger an abort. So, when things go right the very first time, it actually, in my opinion, is pretty impressive. So it's, almost expected to have some issues occasionally. But I think their history of not having issues is actually very impressive with Starship so far.
Indeed. Just want to note one thing for our audiences, whether you're watching on Spaceflight Now or Lab Padre, you'll notice at the top of the screen our countdown clock, which is just a little bit ahead of what's coming through the SpaceX feed in the big box. Reason for that is our clock is in real time. What you're seeing from SpaceX is coming in on a slight delay. So as we're making our call outs based off of the events with the mission, as we have views of the rocket and can make those call outs based off of what our tracking cameras are seeing, we'll make those based off of real time. And then once we are relying solely on the SpaceX onboard cameras, then we will shift to making the call outs based off of the SpaceX timeline. And as you can see with the fueling process, we're a little more than halfway on the ship upper stage, 44% methane on the booster. About a third of the LOX tank on the booster has been filled at this point, all making sense since obviously booster LOX was the last fill item to begin.
Yeah, I really love these drone views. It's amazing how far the technology for drones has come. Because I know when I first started, uh, flying drones, you were never getting more than like 7 minutes in the air, and that was, if you're hovering most of the time. And now they're pretty much able to stay up there for, I've seen it as long as 45 minutes, so it's pretty impressive.
Yeah, and the altitude and the precision of the tilt and panning that the drones can accomplish when Starship is in flight is also really quite impressive. So hat tip to the drone team there at SpaceX for bringing us those views. Also, as we're currently T-minus 23 minutes, 34 seconds and counting. For those unfamiliar with Zach Golden, he runs the CSI Starbase YouTube channel where they do deep dives on the comings and goings there at Starbase and the development of the Starship program. We had a chance to talk about the couple of recent videos that you posted, part of your three-part investigation there. What can folks expect on your channel in the days and weeks to come, Zach?
Yeah, I'm currently working on part 3 of that series, so did have a slight setback just, with work and everything, but my goal with that series was basically to kind of cover something that doesn't get quite as much attention. People are mostly focused on the actual launches, and, not as much information, especially from SpaceX, about some of the stuff that goes on behind the scenes as far as what it really takes to achieve rapid reusability. So, in my opinion, most of what we've seen over the first 8 launches, it has really been like a massive R&D experiment, or for rapid reusability of stage 0. So you could argue also, of course, with the vehicles, but stage 0 is its own thing. And after every launch, they are essentially trying to reduce the turnaround time for the actual launch mount as much as possible. So they kind of worked their way. I think their best was 22 days. And but they need to reach a point where they're able to ideally be able to launch multiple times a week. So a lot of this development has been figuring out what works, what does not work. What are their pain areas as far as things that require constant refurbishment in between launches. So in the first 2 episodes that series, I pretty much covered the first 7 flights of Starship, where all of the refurbishments, all of the upgrades that were required to get the launch mount back into operational status. So for part 3 of that, I will basically be covering all of the known changes to the launch mount for Pad B, and kind of explain using the information from parts 1 and 2 why it was necessary to make certain changes. So I've always personally been a little bit more interested in the ground systems and the vehicle at times, because one of the blessings about them being located where they are is that for the last 4 or 5 years we've basically had live stream cameras on site, being able to not only watch the construction of vehicles as it happens, but also the facilities as well too. So pretty rare opportunity to actually be able to see this much detail. So in my opinion, a bit unprecedented having as much information as we do. So I try to put all that together so people can actually get a better appreciation for what goes on behind the scenes. And for as long as we still have access, I'll probably continue doing that.
Well, we certainly appreciate the insight that you and your partners can provide to the rest of the space community about those intricacies with the ground systems that I think, to your point, largely go underreported by a number of outlets. So, certainly admire the work and appreciate what you do, Zach.
Thank you.
Just taking a quick look at where we are here, T-minus 19 minutes, 50 seconds and counting. We are now less than 10 seconds away from the Raptor engine chill. Speaking of the infrastructure of Starship, this is a good question to segue from that part of our conversation. This coming from Rock and Ryden, asking what material is used for the heat shield, and does it have to be replaced after every launch? Which of course leads into what SpaceX is trying to do, which is to have the answer to the latter part of that question be no, to create a type of heat shield that doesn't necessarily need to be wholly or largely replaced, but that can be inspected and fairly quickly turn around. But Zach, do you want to expound on what material they currently use, and maybe just a peek into some of the experiments that they've got running on today's flight?
Yeah, I'm not the greatest with that. I mean, I do know that they are a ceramic tile, very similar to what was used on the space shuttle. Obviously, the form factor is a little different, and they're basically intended to, never, that's the long-term goal, is to never have to replace them. So with that said, what works in some locations doesn't work in others. So they may have a range of different tiles that are used in the future. As I mentioned earlier, they're currently testing some metallic tiles and some actively cooled tiles. So there may be certain regions on the ship where, they may need additional help, and just increasing the tiles alone doesn't necessarily do the job. So I think some of these different versions of tiles will probably be seen in specific locations on the ship in the future. So right now they're just trying to gather that data so they can make informed design decisions on how to best create an actual rapidly reusable heat shield.
looking forward to seeing the demonstration with, assuming today's mission goes farther than Flight 7, some of the data that comes back on the various experiments that they've got going with the heat shield and some of the different ways that they're looking to protect the ship upper stage through systems like we talked about last time around with active cooling and metallic tiles and all kinds of methods to try to crack the code on what might work best. And the answer may be, the hodgepodge sounds a little haphazard, but maybe mosaic is a better term, where you have different solutions on different parts of the ship that work best depending on what they're expecting to see during peak heating as the ship comes back through the atmosphere and targets a landing currently in the Indian Ocean, eventually back at Tower B. Of course, SpaceX also eager to learn more about the Block 2 design with the changed forward flaps, marked difference between what we saw with the Block 1 ship upper stage.
Yeah, I think that's had to take some time to grow on people, but I think it looks a lot better now. It is interesting to see how it looks in flight, with those flaps being a little bit more on the leeward side of the vehicle. So, I think that we'll probably see a little bit better performance as far as not having burn through of the actual attachment points on the flaps. So yeah, I mean, I think their new placement should keep them a little bit further out of that plasma stream, and hopefully they will be in much better condition by the time they land it.
Yeah, lots of learning to come from this flight, certainly on all aspects of the vehicle. And as you can tell by the frost line, a nice visual indication that fueling is moving along. Seems like smoothly, as we're currently T-minus 15 minutes and counting. Prop load should wrap up on the ship upper stage at about T-minus 3 minutes and 20 seconds. And booster prop load will finish up about 30 seconds after that. Also, as we're cruising on in towards the end of our countdown here, towards the planned liftoff of Starship and the Super Heavy booster, if you haven't already, you could do a big favor for Lab Padre and Spaceflight Now, whichever channel you happen to be watching through. Be sure to click that like button. And if you're not already, subscribe to the channel. Share the stream with your friends and family and fans. Allows more folks to find their way into this live coverage as we're approaching liftoff of this Starship rocket on its Flight 8 suborbital test. Question here from Sarah KB7. Now, showing up on the screen, but I'll read it out real quick, asking why does NASA keep sending its aircraft to be in the vicinity, I'm paraphrasing here, of the SpaceX launches, Starship in particular? Well, that's of course because the Starship vehicle is part of the Artemis program, a key part of Artemis, since a version of Starship will be used as what's called the human landing system, essentially the hardware that'll bring humans down to the surface of the moon and then back up again to, on Artemis 3, dock with the Orion spacecraft, and as it's currently designed in Artemis 4 and beyond, to dock with a space station called the Lunar Gateway, where astronauts will transfer from Starship into the Gateway and then over into the Orion spacecraft before they make their way back to Earth. And so as SpaceX continues to iterate and further development on its Starship rocket, it's obviously key for NASA to know and understand how things are progressing and to make their own observations in addition to what's shared from SpaceX. So good question there. And Eric Scott asking, are they planning to catch the booster and ship in a single mission? Well, the answer to that is yes. The better question, or maybe a secondary question to that, is when, which we discussed just a little bit ago. And the answer to that is potentially soon, but that'll depend on a lot of factors that we discussed a little bit earlier.
Yeah, they're aspirationally want to do it on the next launch. I don't think they may have actually said that already. I'm not sure if they've confirmed it, but you can kind of tell just by the way they're moving as far as with qualification testing on test articles and working on Pad B launch tower where they will be catching the ship. They kind of telegraph this stuff so you can really see that they're doing everything in their power to try and do the first ship catch attempt on Flight 9.
Yeah, I think that's certainly something that Elon Musk, the SpaceX founder, has projected, like you said, as certainly a possibility for Flight 9. And I think how well Flight 8 turns out will certainly be informative as to how close we are to a ship catch. Certainly, it seems like they've got some of the regulatory paperwork in work to move towards that. Taking a look here from our camera over on South Padre Island, you can see there are a growing number of boats in the channel there that are gathered outside of the exclusion zone to be able to get as close of a vantage point from the north side of Starbase as possible. So it doesn't look like the waters are too rough either, so hopefully it will be good viewing for folks in the area and those boats and at SPI as well. It's now 10 minutes to liftoff. Taking a quick look at some of the marina assets that are going to be set out in the Indian Ocean to capture views of the ship upper stage as it splashes down in the Indian Ocean. Supported, of course, by Starlink. Doing a bit of a movement test here on the flaps. Those forward flaps that we were discussing a little bit ago.
Yeah, I really like the way those tuck in their new configuration.
Yeah, it seems like it can get a lot more flush to the rocket when needed, which is probably going to be nice.
Wow, being able to see the aft flaps as well here.
Yeah, I believe commentator Chris Gebhardt said they have somewhere in the area of 30 cameras across the vehicle. So assuming we get a launch here in the next 8.5 minutes, we should see some pretty spectacular views throughout the course of the flight today. SpaceX commentator Kate Tice noting that they're currently working no issues on ship or the Super Heavy booster. Range is currently green, and they are tracking no weather issues out in the Gulf or in the Indian Ocean. So things as far as logistics towards a launch seem to be in a good configuration. And for those that are in the area waiting to see a launch for themselves, visibility also markedly better this go around than last time. So hopefully all goes well. We should be able to see a good launch coming up here in 7 minutes and some change.
All right, just about 6 minutes out. This is going to be very exciting.
Exceedingly so. Also looking forward to, if all goes well, with the PEZ dispenser, as SpaceX likes to call it, the deployment of those simulator Starlink satellites. 4 of them are on board this flight today. The deployment demonstration, if all goes well, that's coming up at about T plus 17 minutes and 24 seconds into flight. Now currently T minus 5 minutes, 18 seconds and counting. Coming up on the conclusion of ship prop load here at now less than 2 minutes away.
Yeah, the one weird thing about this is no matter how many I see, I always start to get nervous within that last 5 minutes. So apologies for the silence over here on my end. I kind of just taking it all in.
No apologies necessary. Honestly, as sometimes happens with launches, you're getting into those last few minutes, that's when things start to happen, both for good and for ill. And so it's good to take a beat to really listen in, make sure we're being fully in tune with what's happening there at the pad and catching anything that may be off nominal. So as you can maybe forgive me for using this pun, silence in this case may be golden. Now T minus 3 minutes, 14 seconds and counting. At this point, ship prop load has wrapped up, and we are awaiting a booster propellant load to conclude as well. Now T minus 2 minutes, 40 seconds and counting. Booster prop load should be complete at this point. Starship should be fully fueled and ready to go here in now 2.5 minutes to liftoff. Again, if they do have to hold. That hold point comes at the T-minus 40-second mark, and they can hold for up to several minutes, as the case may be. Now less than 2 minutes. We're now T-minus 1 minute and counting.
I can hear Dave Avery in the background over there. I'm guessing you're at the Raptor or Rocket Ranch viewing point.
Now 40 seconds out at this point in real time. This is when they would be holding if they needed to, listening and watching. And in fact, holding at T-minus 40 seconds. So we'll cycle our countdown clock back to T-minus 40 seconds. Sounds like they're working a temperature issue. Unclear if it's on the booster or the ship upper stage. Clock has resumed. For that go for launch call, we're now less than 30 seconds away. About 13 seconds to go. See the water deluge system go. We've got 9, 8, engines ignition, 6, 5, 4, 3, 2, 1, and liftoff. Liftoff of Starship Flight 8. And Starship has cleared the tower.
20 kilometers an hour. Watch the Mach diamond, longest Mach diamonds in the world. 190 kilometers an hour. 300 kilometers an hour. 400 kilometers an hour.
Actually, kind of nice getting those live sounds coming in through your mic. That is what it sounds like out there. It is probably extremely loud, so difficult to not have that come through on the microphone. Definitely awesome to see this in person if you guys get the chance one day.
Yeah, as we're a little more than a minute in real time into the flight. Passing through max Q, point of greatest aerodynamic pressure on the vehicle. Coming up on a few milestones, we'll see booster most engines cut off for MECO. That'll be followed by hot staging and the start of the booster boost back burn. At that point, they'll make the call on whether they're in a position to catch the Super Heavy booster or divert for an offshore landing. Watch in the bottom corner of your screen for those 6 Raptor engines on the ship upper stage to come to life before hot staging.
34 kilometers altitude.
Initial call that they are go for booster catch.
There we go.
See if that remains true throughout hot staging. Coming up on hot staging, Miko. And there you see that hot staging in real time. We're seeing that on the SpaceX feed now as well.
Wow.
And
That
it looks like
ground
we've
camera
got
looks really good.
2 engines out on the center ring on the Super Heavy booster out of the 13 expected to relight. All 6 Raptors on the upper stage have lit, though. They pulled go for booster return. A little more than 3.5 minutes into this mission, the boost back burn shutdown has happened. Hot stage rings should be jettisoning here momentarily. Down to 3 engines on the boost pack burn. Now about 4 minutes into flight. Call for a boost back shutdown. That hot stage ring jettison's coming up here next. And there you can see it falling away from the Super Heavy booster. And Zach, that's some of that prop venting that you were talking about earlier, right? That little puff that we're seeing.
Yeah, exactly. You can see that puff coming out of the bottom of the booster. It's would look a lot different at sea level because there would be less expansion. But yeah, they got to empty out that main tank as much as possible, and they're also trying to drop the internal tank pressure as well too. So that's why you'll see that.
Now a little more than 5 minutes into flight. We've got about 1.5 minutes before we see the landing burn start up. Landing burn start coming up here in about a minute. Now a little more than 6 minutes into flight. We'll see the start of the landing burn begin in real time. Our camera on the right. Landing burn start in real time. Closing in on the tower. And it looks like a good catch of the Super Heavy booster. Once again for
Awesome.
a third time. And it was right about this time last go around where we started to see some of the engines having issues on the ship upper stage. So we're watching that telemetry data on the right-hand side of your screen in the bottom corner. But so far, it looks like things are remaining healthy with the ship upper stage so far. Continues to increase in its speed. Currently 144 kilometers in altitude. Starship engine cutoff is now less than a minute away. And we are seeing some of those engines going out ahead of schedule.
Oh,
And it looks like we're in a tumble.
Jesus.
Really marked tumble. Would expect
That
them to
is-
lose communications shortly.
That is not good.
We'll see if they have communications long enough to trigger the automatic termination system. But this is markedly not what they wanted to see with this second flight of a Block 2.
Yeah, that is very unfortunate.
Let's listen into SpaceX commentary to see if they have any additional information about what's happening.
So we'll continue to stick with it.
Down to one Raptor engine.
For those of you that just recently joined us, we had a successful liftoff of the 8th test flight of Starship, followed by a successful stage separation. We saw the booster, actually, you can see it just behind us here. The booster had a successful catch back at the tower. Unfortunately, it seems as though we lost the attitude control of the ship. We are standing by as we listen in with the teams on the nets to understand what information we're able to provide you. We will provide that as soon as we are able, but it's pretty incredible to take a moment and see the booster just behind us. Certainly a different view than last time.
And at this point, we've essentially lost contact with the ship. We're no longer receiving telemetry at this moment. So we were only about 20 seconds away or so from the end of that ship ascent burn. We saw several of the engines start to cut out. Once you lose enough of those center engines, you're going to lose attitude control. And so we did see the ship start to go into a spin. And at this point, we have lost contact with the ship. So we're going to listen in for a little bit. I think it's pretty obvious we're not going to continue the rest of the mission today, but just give us a couple more minutes. We'll bring you more information as it comes in.
For those of you who may just be joining us, of course, we are in the process of covering Starship Flight 8, where almost like deja vu, we saw a catch of the Super Heavy booster, and once again, at nearly the same point in flight, the loss of attitude control with the ship upper stage. You saw the Raptor engines on Ship 34 drop out one by one. And getting some reports that the ship may be visible from Central Florida. Working to see if we can get some images for you. If you're in Central Florida or in South Florida and you happen to be seeing the status of the ship upper stage, step outside if it's safe to do so, snap a video or snap a photo, take some video, and tag us on social media at either at Lab Padre or at Spaceflight Now. I'd love to see from your vantage point what you're seeing.
So there will not be a catch attempt on Flight 9.
Yeah, I think that's, if there's anything definitive you can say about what comes next, is that it would be a decided shock if they were to proceed with a ship catch attempt with Flight 9. I can't imagine, given the circumstances.
Yeah.
And it sounds like we've got sorry to cut you off, a video of visibility coming in from Orlando.
All right, so coming back with you real quick. So can confirm we did lose contact with the ship. Unfortunately, this happened last time too, so we've got some practice at this now. We've got a lot of measures in place, like debris response areas where we coordinate very closely with air traffic control. We have a lot of measures put before we ever launch a rocket to make sure that we're keeping the public safe. Those worked last time, and they're actively in work right now. So just to recap real quick, everything we saw, we lifted off right at the top of our window, essentially at 5:30 p.m. Central Time. Booster was able to get us all the way up into space, made its way back here. It's sitting on the tower right behind us, our third ever catch. Starship ignited all 6 of its Raptor engines. It was just about 20 or 30 seconds away. We'll get exact times from the end of its ascent burn. When
we are starting to see some video
eventually
of
lost attitude
debris
control
falling.
and then lost contact with the ship shortly after.
Falling over
obviously
Florida
a lot to go through.
But we are seeing some videos start to come in from photographers and folks in the Central Florida area, including at Cape Canaveral. Seeing some video reportedly from North Florida as well that was able to see the ship as it was making its flight as well. So we're working to get permission to share that with you. And of course, as soon as we have that, we'll bring that into our coverage. So Zach, beyond obviously how the SpaceX team must be feeling at this point in time, your thoughts on essentially having a repeat of Flight 7, but very much not in the way as folks were anticipating.
Yeah. I mean, it feels like basically, as you mentioned, happened around at the same time. And obviously the sequence of events kind of seems very similar to Flight 7, which makes this kind of feel like an inherent issue with the overall design of the propulsion system on the version 2 ship. So I think they did believe they had solved it. At the same time, this is deeper into the second stage burn than what they're able to test for. So again, with that long duration static fire, it was about 60 seconds. What was the burn time on this? Do you happen to have that?
When it started to fail? Let me see if I can find that specifically.
I mean, it's basically about 5.5 minutes, right? So
Yeah.
Yeah, I think that, without being able to do a full duration test, which is, the complete burn of the ship, it may be hard to identify these problems. And at the same time, the dynamics in vacuum are a little bit different than what you're able to test for on the ground. So they may not be getting the same type of like resonant response in the engine plumbing that they're actually seeing in flight. And so that may make it difficult for them to actually verify that the problem has been solved without actually flying it. You know what I mean? So hopefully this is an issue that can be resolved. Obviously, they knew how it failed the first time, so assuming that there was some mitigations in place to prevent it from happening again, they hopefully, a second time might be a charm as far as addressing the issue, and hopefully it's not an actual overall design flaw that will force them to kind of go back to what they were doing previously as far as that engine plumbing goes.
Yeah, that would certainly be the hope that this is something that can be resolved fairly expeditiously. We're looking at some video now, shot from Central Florida. This shows just before the breakup happened. We're working to bring you some images of the ship breaking apart as well. Okay, what you're looking at here is an image shot by Doug Jacobson. This was captured just near the Latana, Florida area. Go ahead to the next image here, and you can see some of the pieces of the ship upper stage, very reminiscent from what we saw over the Turks and Caicos Islands south of Florida from the Flight 7 mission. Presumably we'll see a mishap investigation be triggered from the FAA, and we'll of course have details for you on that as soon as they become available. Well, with that, of course, we will continue to gather details and information about the aftermath and the finale of Starship Flight 8, and we'll have updates for you as we learn them both on Lab Padre as well as Spaceflight Now's social media channels, as well as on our website, spaceflightnow.com. I'm sure we'll also see more from Zach and his CSI Starbase investigation and taking some of the things away from today and seeing how they factor into learning for Flight 9 and what that might look like. But before I let you go, just want to say thank you, Zach, for all your insight and wisdom. And mention CSI Starbase is obviously folks can find your work there. Where else can our audience keep up with you if they'd like to track what you're doing?
Yeah, I'm also on X as well, CSI_Starbase. Feel free to follow me there. I also, as I mentioned earlier, have those part 2 of 3 out for my current series. Almost feel like I gotta, break away from part 3 and do something about this version 2 ship, but I don't know. We'll see how that goes. But definitely subscribe on the CSI Starbase YouTube channel and check out those videos if you have not already, and be on the lookout for more in the near future.
Awesome. Well, thank you so much, Zach, and look forward to talking with you more. And hopefully it'll be on a flight that goes as planned next time. Talk to you later, my friend.
All right. Take care.
And want to thank the team behind the scenes on both the Lab Padre and Spaceflight Now side of the coin for all the hard work to make this live launch coverage possible. A big thanks to Lewis, to Ezra, to Steven, to Chief, all of our moderators on both channels holding it down in the live chat. Big thanks to all of our channel members who make these live launch opportunities possible. We'll, of course, be back with live coverage of Starship Flight 9 whenever that is scheduled. In the interim, you can always head over to Lab Padre's YouTube channel and check out 24/7 live views of a multitude of angles from around Starbase and continue tracking the progress of the Super Heavy booster that was successfully caught. Don't want to overlook that bit of engineering success from SpaceX in ticking that box once again today there at Launch Tower A. And of course, we'll have coverage at Spaceflight Now of the upcoming Falcon 9 launches, Starlink flight, as well as NASA's SphereX and Punch missions lifting off on the same Falcon 9 rocket. That mission getting punted now to no earlier than March 8th from Vandenberg Space Force Base. Once again, want to thank everyone with Lab Padre, everyone with Spaceflight Now for making our live coverage today possible. Most importantly, though, want to thank you, the viewer, for being here with us today. If you haven't already, be sure to like this video on whichever stream you're watching and subscribe to both Lab Padre and Spaceflight Now on your way out the digital door. Much to come in the coverage of the Starship program, and we'll be very lucky to have you joining us once again next time when next SpaceX is ready to launch. Big thanks to Rocket Ranch for their hosting us as well in our ability to track the rocket today and in an ongoing capacity over on Lab Padre as well. Thanks to those folks. Tip of the hat to all of you for being with us, and we will see you next time, folks. Until then, bye-bye.